Here in this video we're going to look at optimization of a volume problem. And the example problem I have is a rectangular box with a square base is to be formed from a square piece of metal with 12-inch sides. If a square piece with sides X is cut from each corner of the metal and the sides are folded up to form an open box, what value of X maximizes the volume of the box? So I'm going to draw a picture so that we can see this piece of metal. So we have a square piece of metal, and we're going to cut corners out, and each of the sides of the corner is going to be X. So we're going to have this in each corner. And now we want to maximize the volume of this box. So the first thing we're going to do is create our volume function. So volume is equal to length times width times height. Now if we look at one of these sides, they told us that it was 12 inches from side to side. Now if we look at it, we need to subtract out 2 x's on this side, because that's going to be the height. So here our volume is going to be equal to 12 minus 2x for a length. And if you look at the width, it's exactly the same. So we're going to have another 12 minus 2x. And then the height is equal to x. That's what we're cutting out of the corner. And now we need to multiply all this together. So we have v of x is equal to 12 minus 2x times 12x minus 2x squared. And now I'll multiply those two terms together. So v of x is equal to 144x minus 24x squared minus 24x squared plus 4x cubed. And now I'm going to rewrite it in gather like terms. Is equal to 4x cubed minus 48x squared plus 144x. And now that we've created a volume function, we can take the derivative of this function. V prime of x is equal to 12x squared minus 96x plus 144. And if we want to find a maximum, once we take the derivative, we're going to set it equal to 0. So we're going to say 12x squared minus 96x plus 144 is equal to 0. And I'm going to factor a 12 out of the function. So 12 gives me x squared minus 8x plus 12 is equal to 0. And now I'm going to write it in linear factors. So I have x minus 6 and x minus 2 is equal to 0. So this shows us that we have a relative maxima or minima at 6 and a relative maxima or minima at 2. And now we need to figure out which one maximizes this box. So I'm going to take the second derivative to find my concavity. So I have v double prime of x is equal to 24x minus 96. And now I'm going to plug in 6 and 2. So v double prime of 6 and v double prime of 2. And when we put 6 into our second derivative, we get 48. And since it's a positive number, we know we're concave up. So it would be a minimum. So x is equal to 6 would minimize the volume of this box. And we're looking to maximize it. So when we do v double prime of 2, we get negative 48, which means we're concave down, which would make x is equal to 2 a maximum. So when x is equal to 2, we maximize the volume of this box.